All right, 2.3, we want to look here at finding domain and range. Those are important. So remember that domain is kind of our input, range is our output. So we want to know what can we put into a function, what do we get out of a function, those types of things. So we're just going to look at that here quickly today. We do have a couple of definitions that we're going to go back here as just a reminder. And so that domain, we're going to just really note that as the x values. Okay, so that is our independent variable, if you remember that part from before, but we're just going to look at it. We know it's the x values, so that's more what we're going to focus on here today. And then our range, again, is the y values. Okay, it's our output or our dependent variable for those pieces. Okay, so we want to look at a few different types of things, different representations, and be able to tell what is the domain, what is the range. We don't need to do mapping diagram like we did the other day because it tells us what the domain and the range are, but we are going to focus on some other pieces, okay? All right, so our first one's actually all of these here. We want to find the domain, okay? And I'm actually going to put and range. Some of the questions may ask for both. They may only ask for one. So always pay attention to your instructions. Always read your instructions in a math course or any course, because you need to know what is the answer you're looking for. Not that you just came up with a bunch of numbers or things like that. But what is the answer? How does it need to be represented? So always keep that in mind. Okay? All right, so our first one's here. Let's see. We have a set of ordered pairs. Right. And so if we're looking for the domain, so let's start with the domain here. Domain. Because these are just going to be numbers, it's going to be a set. Remember that our domain is the x values. So 1, -3, and 7. There, it doesn't matter the order. If you want to put it least to greatest, you can do that. I typically just work through my ordered pairs and list out those x values. And then the range, so that's the second number, or y values. So we have 2, 8, and -4 for those, okay? And so that's all it would be there. You're just listing out those pieces on them, okay? All right, now, of course, it's not always just going to give us ordered pairs. We've got to look at some other things. And so our next one here is we want to look at the graph. So let me draw a graph real quick. Pretty basic graph so that we can see what's going on. All right, so here we have a linear equation, and we want to know what is the domain and the range. So we've got to pay attention to a couple of other little details here, okay? You'll notice these things are going, we have arrows on them, which means they go forever in that direction. But they are, this is what we call a vector, if you were to do like physics and things like that. They're actually doing two things at once. So for instance, this top arrow here, it is going to the right and it's going up at the same time. So it's doing both of those things. And this one here is going to the left and down at the same time. Okay? All of those things are happening within this graph. Now, if we're going to the right, talk about number lines, that takes us out to positive infinity. This one takes us up to positive infinity as well. This one here is going down, which is negative infinity, and to the left is negative infinity. Now, those things are important as we look at our domain and range, right? Because when we look at a line, we cannot list all the x values because it goes forever. Here, even when we look at this, even though we can see these numbers, all these little decimals in between there is also being counted. And so we can't possibly list them all, right? So when that happens, we have a line, we're going to represent this a little bit differently. So let's look at our domain. We want to recognize all of those x values. Well, let's start with our x values as left and right. So how far left does my line go? Well, it goes left to negative infinity. Then we ask ourselves, how far right does it go? Well, it keeps going right, and it goes right to positive infinity. Okay, so we go from negative infinity to positive infinity for that domain. Every x value is being used at some point, even if we can't see it, it is being used. Now we do have to notate this correctly. Infinities, for our purposes now, for right now, is going to get parentheses, okay? So infinities will always get parentheses. What those parentheses represent means I go all the way out to that number, but I can never equal infinity. Infinity is just a representation of it goes forever. So we can never say it equals a certain number. So a parenthesis represents that we go out to infinity, but we are never equal to infinity because that's not possible. All right, now how about our range? Well, range is up and down. We always start lowest to smallest, so we're going to start down. How far down do we go? So we go down to negative infinity. Then we go, how far up do we go? So in this case, this keeps going up to positive infinity. And again, infinities get parentheses. Okay? So much like those, you just have to remember what direction am I going? Domain is left and right. Range is up and down. All right, let's look at another graph. Okay. All right, so this time we have our parabola. And so we want to look at what's happening with it. Now, again, it has arrows on it, or it goes off your graph. On the computer, it may just go to the very edge of your graph. It won't have arrows. If it goes to the edge of the graph, it means it goes off the graph and keeps going forever. So keep that in mind, right? So when we have that, we look and see, okay, this arrow says it's going up, but it's also slowly moving. As you can see, that graph is moving out. It is moving in that direction, okay? So going to the left means negative infinity. Going up here means positive infinity. Our other arrow, well, it's also going up, so that's positive infinity, but it's going to the right, which is positive infinity, okay? Now, none of them go down. That's fine. We'll look at how that affects our range in just a moment. Let's start with our domain. We always want to know what we can plug in first. So how far to the left do we go? Well, to the left, it goes to negative infinity. How far to the right do we go? Well, it goes to positive infinity. And it should always be in that order, negative infinity to positive infinity. It's always less to greater when we're writing things, just like a number line. So make sure you do that properly. Now range. So what's the lowest place of our graph? Well, we look at our blue line, nothing goes lower than right here, which is at 1. So our lowest number in this case is 1. Our highest number, it goes up forever in both cases, which is positive infinity. Now the infinity gets a parentheses. For now, any number we're going to go through, and that's going to get a bracket. Bracket means we equal that number. So we notice my line touches the 1 on the graph. That's equal to it. Okay. There are cases that we get really close and don't. We're not going to have to worry about that at this point. We'll get into that maybe later or in another class with another course for that. But at this point, we're not going to worry about that. Infinities get a parentheses. Numbers get a bracket is what you need to remember for those. Okay. So that's how you would approach that problem. Now, we can move those things around, and those numbers can be in different spots. It can be on the domain. It can be in either part of the range with them. So pay attention. Does it go down forever, up forever? Those types of pieces so that you recognize where to locate those things on the graph. Okay? All right. And we've got one more representation we got to look at here. So those were graphs. We looked at ordered pairs. But another way that we look at our relations are through equations. And so we need to look at how to represent those pieces. Okay. All right. Now for here, we're just going to find the domain only. We're not going to worry about the range at this point because of the way kind of equations work. It's a little bit more in depth, and we're just not going to do that at this point. We may come back to that later. All right. So f of x equals 2x plus 3. All right, so when you're looking at an equation and you want to know about the domain, we want to look for two things and see if they happen. Do we have a fraction with a variable on the bottom? Do we have a fraction with a variable on the bottom? If that is the case, then we have a problem and we need to find that. Okay, we'll talk about that in a moment. Don't worry. The other would be, do we have a square root? In this section, you're not going to have to worry about square roots. We're not going to talk about that. We are going to do those for sure later on. I think unit 3 maybe. We will look at square roots and we'll talk about those. In here, you will not, in this section, in this unit, you won't have to worry about that yet. Okay. So really our question for this section is, do we have a fraction with x or a variable on the bottom? Here I do not. So since I do not, that means that my domain is all real numbers. Okay, all real numbers. Now, if it wants interval notation, you would say negative infinity to positive infinity. This is that interval notation. Okay, which we wrote over here, this piece. Right? Now, if not, they may have it written out, all real numbers, and that's okay. You can select that if that is the case. All right. And so just kind of to show you another, g of x equals absolute value of x plus 7. Okay. Again, we do not have a fraction with x on the bottom. So even though I threw the absolute value bars in there, it didn't change anything for my domain. So my domain is all real numbers. Okay. So that's what you're going to look for there. Right. 2 over x plus 3. All right, so this time we have an x on the bottom of a fraction domain. So that's a problem. The reason why it's a problem is if we end up with 0 on the bottom of our fraction, that is undefined. It's impossible to divide by 0. Okay, so we've got to account for that. So we want to figure out that piece. For my domain, what we're going to do is we're going to say here we have x plus 3, and x plus 3 cannot equal 0. So notice I have an equals with a slash through it. That means cannot equal. It can be any other number but 0. It cannot be 0 for those. Okay. Well, we can solve this just like a regular equals. So So we're going to subtract 3 on both sides. So if I subtract 3 here on both sides, that tells me x cannot be -3. Now it can be any other number but that. So that tells me here that I'm going to get x such that x cannot be -3. Okay. Now you might not have seen this notation before. Here, this is what we call set notation. This bar means such that. So this is a sentence that tells me that my domain is all the x values such that x cannot be -3 for those. Okay. Now they're going to have most of that. You're going to be filling in that x cannot be -3 part there on those. This is what you'll be typing in those problems. Okay. All right. So let's look at just a couple more. Right here, I've got 5x over 5x minus 14. And so again, our domain, we're going to take this bottom, 5x minus 14. We don't care what the top is. The top can be full of variables. We do not care. We only care about the bottom. And it cannot be 0. So then we add our 14 over. Cannot be 14. 5x cannot equal 14. We divide by 5. And so x cannot be 14 over 5 for this problem. Okay. All right, let's do one more. I'm going to squeeze it in right here. We should have enough space. Number 5. It says f of x equals -2 over absolute value of 2x minus 7. All right, so again, our domain will be absolute value of 2x minus 7 cannot be 0. So we're taking that bottom, setting it not equal to 0. Well, the good thing is for absolute value, even though we've not talked about solving with absolute value, for 0, we really don't need the absolute value bars. Okay, so we can rewrite this as 2x minus 7 cannot equal 0. All right. So now, very similar to number 4, we're going to add the 7 over and then divide by the 2. So x cannot be 7 over 2. Make sure you reduce those fractions if you can for those pieces. Okay. All right, so those are the things that you're going to need to look for here when finding domain and range. Make sure again that you pay attention to your instructions. Do you need both domain and range, or do you need just domain for those problems? What do they give me so that I know what to look for and how to approach those problems? All right. So make sure you're getting in and getting that done.